is subset of y1. It's for sure.
So for every such alpha, I have such an expression. Okay? For every such alpha. Because for every such alpha, that's a linear combination. So I have loads of linear combination. Can I take alpha to be 0? Take alpha to be 0. So if the alpha is 0, what does it mean? It means that g1 of y
Is equal
is
to
same as
f tilde of y.
f tilde of y, and don't forget that y is one from
domain of
f tilde. So what does this show? This shows that g1 is linear extension
F tilde.
of f tilde.
which contradicts to the
No, still it's not contradicting. Still not contradicting. There is something missing. No, obviously one thing is there actually, that g1 is bigger than, in some sense f tilde. But is it bigger than in the order sense in E actually?
to subset
In the order sense. So in other words, does g1 belongs to E? That's what we would like to prove. So in order to say that g1 belongs to E, you have to not only have to show that it's an extension, but you have to also show that
The element for
G1 is bigger
so
than
g1 of x is less than or equal to
p of x.
p of x for all x in the domain of for all x in y1 whatever it is. So you have to show that. Still not done. But if we show that, that would be a contradiction. We will be done with the proof. Okay?
मतलब ये दोनों करनी पड़ेगी ना, एक डोमेन को सबसेट ऑफ डोमेन ऑफ g1 करना पड़ेगा और वो g1 को लेस देन जो आर्डर हमने डिफाइन किया था उसी आर्डर के मुताबिक ये मतलब एक्सटेंशन को मेक श्योर करेंगे g1 is really
This is making sure that domain of g1 or domain of f is indeed included in y1 actually. Because y1 is spanned by a domain of f tilde and something which is not in domain of f tilde. Okay, so it's indeed there. So extension is there. So the only thing that you need to verify is that some linearity condition is true actually as well. Okay. So next we would like to show. We would like to show so next claim is, which is we can say roughly or part or step 3. Okay, it is not that straightforward. So next claim is that g1 of x is less than or equal to p of x for all x in the domain of g1, which is y1 x. Agree? ठीक है ना भाई? सोच में पड़ गया. I know the proof is a bit longer, but it's straightforward. Straightforward. Pretty straightforward. Now, once we prove this, what's going to happen? The g1 will belong to E, and that would be a contradiction to the maximality of f tilde, and hence, what would be true? The true would be that domain of f tilde is whole x. This is what that you want to show. Okay? Because this contradiction is coming because of, assuming that there is something missing in domain of f tilde. And we said that we can take that missing thing and create a new functional element space, okay, an element in E actually. It's a very clever proof actually. It's a very clever proof. But it's natural. Okay. so, so what would be our strategy? Our strategy would be that we are going to cleverly choose this C, which we left actually open, in such a way that this condition is satisfied actually. So that's what we do. Okay? In order to do so, consider this. So let's take y and z from domain of f tilde. Okay? So consider this. So what would be f tilde of y minus f tilde of z? Okay? So since it is linear, f tilde is linear, so I can write that f tilde of y minus z, and I know that f tilde is from E, so this condition is satisfied, P of y minus z. Agreed? But
P is sublinear.
sublinear है, but I'm going to use sublinearity. Let's say that I have y1, y plus y1 minus y1 minus z. Agree with it? Okay. And now I'm going to apply sublinearity, that this is less than or equal to p of y plus y1 minus p of y1 plus z. So this is true in general. Maybe plus and minus inside. Agree? And this y1 is what? This y1 is the same y1 which is missing. Okay? So don't forget that. You have this. And from this, it's just simple calculations actually. From this inequality I can also follow that minus p of minus y1 minus z is less than or equal to minus f tilde of z is less than or equal to p of y plus y1, okay, minus f tilde of y. Okay, let's give it some name star. ठीक है? Okay. You just took this on other side and this guy on this side. Okay. Alright, so the next thing that I would like to say is that, I mean, if you see, y1 is fixed here. Okay, just like a y1 is fixed here, and what? Z is variable. And on this side you have only z, and on this side you have only y is active. Okay, so what can I do is that I can, for example, somehow fix this z and take the supremum on y actually. This would still hold. If I take a supremum of y's on this side, that would still hold. Okay?
The y arbitrary.
Y arbitrary. Z be arbitrary.
वैसे तो I
can just take one of them. Okay? Because these both expressions are explicitly independent actually. Okay? So you don't have a y here, you don't have a z here. So if I fix z and treat y as an arbitrary, okay, then I will say that okay, this expression is less than or equal to supremum of all that. Are you getting the point? Or I can also take supremum here actually if I fix y. I can. So I can take supremum on this side, and I can.
One is infimum.
It infimum what होगा?
Probably you need to take infimum here.
One side.
Okay.
M1 is infimum.
हाँ.
Now it should be okay. Now it should be okay.
सर
It's okay.
n2 वाली साइड सुप्रीमम
M1
bigger
is-
side.
One is infimum.
हाँ.
तो फिर उल्ट होना चाहिए.
Yes, sir.
Yes, sir.
ये होना चाहिए.
Yes.
Then you must have something
Sir,
like that.
same रहेगी.
Huh?
M1 को just name दे दे वो infimum.
I'm relying on your calculation, so you need to tell me things correctly. So what I am saying that C is bigger than or equal to this infimum, and not, and less than or equal to supremum. So C is,
पता नहीं
First
क्या है.
is supremum.
सर पहले को सुप्रीमम रख दे, दूसरे को इन्फीमम रख दे सर.
what do you mean by?
यहाँ पे सुप्रीमम, वहाँ पे इन्फीमम.
यहाँ पर supremum रखें, वहाँ पे
हाँ सर. Then it would work.
पक्की बात है?
Yes sir, पक्की बात.
Alright. Supremum, okay. So we must take supremum of this guy here and infimum of this guy here. Okay? Up to you.
अब ठीक है.
Yes, sir.
So M naught is less than or equal to M1. And I can legitimize this inequality as well. Okay, we are almost there. Okay, but we have to prove it also. So let's finish it. 5 minutes लगेंगे. Okay, let's finish it. So let's give it a name actually. For example, double star as well. Okay, let's give it a name. So what was our key objective? Where we want to reach? We want to prove this actually. Okay. So now the trouble here is basically this alpha, because this alpha can be anything. So I'm going to say that when if alpha is 0 or alpha is negative or alpha is positive, in all three cases you have this actually. Okay. Alpha is equal to 0 is trivial. You don't have to prove it actually.
Equity.
It's there because f tilde and f tilde is less than or equal to p of x. So the interesting case would be to consider the case when alpha is negative, for example. Okay? Alpha is negative. So if alpha is negative, okay, replace, okay, in this part, okay, replace in this part, replace z by, not in whole inequality, by, okay, by alpha inverse y. Alpha inverse y. So if I replace it, what I'm going to get?
minus p
Minus p minus 1 minus
alpha inverse y
alpha inverse y minus f tilde
alpha inverse y
alpha
minus नहीं
alpha inverse y is less than or equal to c. Agree?
yes sir.
Alright. So what? So if I multiply now throughout by alpha, what I'm going to get? I'm going to get minus p of alpha y1 minus y, okay, minus f tilde of y, and it's less than or equal to alpha c. Do I need
Sir.
to? No, but let's apply by the minus alpha, because then the equality.
हाँ, then
Okay? So if I multiply everything by minus alpha, then what's going to happen? So this will become plus, and this will become plus 2, and I'm going to have a minus. Agree?
ना Positive.
Inequality में तीन इधर है. Okay.
Alpha negative or minus alpha positive.
But here is the thing. I know that my any x in the space y1 can be written as
Minus alpha.
y plus alpha y1. Okay. Okay. Y plus alpha y1. So keeping in view this, consider the g1 of x. So what would be g1 of x? So the g1 of x is going to be by definition.
G1 of alpha y plus alpha y1.
So it's going to be f tilde of y plus alpha c. Agree? And if this is the case, think about it. If I take this quantity on the other side and this on this side, so I would say that this is less than or equal to minus, which is going to be inside again. So it's going to be p of alpha y1 plus y, which is same as b of x. Correct? Okay? So you showed it for when alpha is negative. And how about, it must be an easy trick now, how about if alpha is positive? What do you think? What we should do? So probably it's a time to use this part of the inequality. Okay? This part of the inequality. So what we should replace them? Okay? So replace y by alpha inverse y. Okay? And take the second part of the inequality. Okay, the second part. So if I replace alpha by alpha y, what's going to happen? So c is less than or equal to p of y1 plus alpha inverse y minus f tilde of
Alpha inverse.
alpha inverse y. Okay? Are you getting the point? And then let's multiply just simply this by alpha. So if you multiply this by alpha, so it's going to be alpha c
Alpha y1
alpha y1 plus y
minus f of y.
minus
F tilde
f tilde of y actually. So if I take this on the other side,
That would be g1 of x.
so if I take this on this side plus alpha c and then less than or equal to p of alpha y1 plus y. Oh, so that's my g1 of x.
Less
And
than
that's my
p of x.
p of x. This is true
For
for all x in
y1.
for all x in y1. And that's a contradiction. Contradiction to maximality of f tilde. Because g1 belongs to E now. That's it. That's it for you. Okay? So, मुश्किल नहीं है. Just pretty simple.